Let's make a demonstration and explanation of self-induction. We will need a bobbin of magnet wire, a 9-volt battery, a neon lamp, and a couple of alligator clips. The neon lamp needs a minimum of 60 or 70 volts in order to work. We can see that if we connect the lamp to the 9-volt battery, it will not turn on. I'm going to connect the battery to the coil. This coil has around 1500 turns. There is no light in the lamp, it does not turn on. Of course 9 volts is not enough for this lamp. However, the lamp will turn on at the moment I disconnect the battery. Let me make a zoom. Connect the battery and nothing happens. Disconnect and the lamp turns on momentarily. Let me show you again. Let me now give an explanation of why this occurs. The first thing we have to remember is that when an electric current circulates through a coil, a magnetic field is created around the coil. This is the principle of the electromagnet. This coil of around 500 turns has an iron core that enhances the strength of the magnetic field. We can see the effects of the magnetic field observing how the coil attracts small pieces of metal when it is connected to the battery. Another concept we need to know is that when a magnetic field moves through a coil, it induces a voltage in the coil. Here we have connected this coil to the multimeter and we are measuring voltage. When we place the magnet near the coil and move it, a voltage is induced in the coil. There has to be movement of the magnetic field. If we only put the magnet near the coil, but there is no movement, then no voltage is induced. The voltage appears with the movement of the magnetic field around the coil. So what is happening with this circuit? Here we have our coil, and when we connect a voltage to the coil, for example with a battery, a magnetic field will form around the coil. This magnetic field is static as long as the battery is connected. In the moment when we disconnect the battery, the magnetic field will collapse. The magnetic field lines will move to the center of the coil and eventually will disappear. This movement of the magnetic field will cut the coil, and as we have seen, a voltage will be induced in the coil. This induced voltage is what powers the lamp that we have connected to the coil terminals. Now we are powering this lamp with this 9-volt battery, and the lamp requires more than 70 volts to work. How is this possible? Well, the voltage that is induced by self-induction in the coil depends on the number of turns. A coil with a few turns will induce a low voltage. A coil with a large number of turns like this, that has more than 1000, induces a higher voltage. The voltage induced here must be about 100 volts, and that is the reason that the lamp works.